Hello, and welcome back to the Rock Code Academy. I'm your host, David Flanagan, although you may know me across the internet as Rock Code. Today is the third episode of our Portainer in Production series. Before we begin, I'd like to say thank you to the team at Portainer for sponsoring my time to put this course together. It's been a whole lot of fun. I'm really enjoying using Portainer, and you're going to see why today. So what is on the menu for today? Well, I wanted to see if I could use Portainer with Equinix Metal together to deliver an application to my customers with as low latency as possible. Now, I can do this with Equinix Metal by using global Anycast BGP advertising to route traffic to any region they support. But it comes with a maintenance overhead. I then need to manage bare metal in Asia, the US, and Europe continuously. I need to update my applications. I need to use something like SaltStack or Ansible to push out updates to all of them at the same time. It's cumbersome. And in fact, this is why we fall back to tools like Docker Swarm, Nomad, and Kubernetes. However, those all bring a level of complexity as well. And I love Kubernetes. I talk about Kubernetes all the time. However, it's a pain in the ass when you have to distribute it and scale it globally. Kubernetes using etcd is a very chatty system, and in fact, it's often encouraged and recommended never to scale your Kubernetes cluster beyond a single region. So if I want to deploy an application to my customers all around the world with low latency, Kubernetes is not a good fit. Now, if I were doing microservices with thousands of services, I'd maybe find a way to make it work. But I'm not. I'm scaling a few containers. So, let's move all of this to a platform designed to do this properly. And that is Portainer. I'm going to show you how to run Portainer in an edge environment. Now, I'm only using 3 nodes around the world. However, Portainer scales and has been battle tested to over 15,000 edge connections. So it doesn't matter if you've got my scale for a few people or your scale for a few million. So let's take a look at the code to spin up and manage Portainer in an edge environment all around the world on Equinix Metal with Anycast routing using BGP. This demo was super fun for me. I hope you enjoy it. Let's dive right in. All right, so today, everything that I'm going to show you is available on the Portainer in Production repository. The link is in the description below. We are using Terraform CDK to automate the provisioning of 4 bare metal devices. 1 Portainer admin node, which will act as the central point for distributing commands down to our edge agents. And 3 edge agents, 3 bare metal devices distributed around the world, all sharing one common Anycast BGP advertisement. This will allow us to request a simple nginx container from anywhere in the world and see very low latency response times. Now I'm going to spin this up in a way that we see it with 2 edge agents, one in the US and one in Europe. We'll see that the response time from Asia and Australia is pretty poor. We're going to bring in a 3rd node and we're not going to install anything to it. We're going to let Portainer do what Portainer does best, which is manage all of these edge devices for us using edge stacks. We'll then rerun our tests and we'll see that we've substantially improved the latency to our customers in that region. And that is the goal, right? We want to be able to have ephemeral, automated compute infrastructure handled for us with all our applications deployed via Portainer with no manual intervention. So let's take a look at the Terraform CDK. Now, we are going to do this in a 2-phase deploy. One to deploy the admin node to get the token that we need, which is the edge key here, to then do the second part of our deployment with the edge agents. Now, we've got the Portainer admin Terraform stack, which uses Cloud Init, and I'll show you the scripts to do the provisioning in just a moment, to handle deploying Portainer as an admin node and as an agent. And then we have the Equinix provider so that we can provision some bare metal devices with a BGP advertisement. We reserve a global IPv4 address on the Equinix Metal network. we build our cloud init configuration, and we deploy the device. Now, I am enabling a BGP session on the admin node. We could, in theory, double down and use that as an edge compute node if we wanted. However, for today, I'm not really doing that. We use Terraform outputs to publish the admin IP so that we can get to the web interface, and the BGP IP so that we can request traffic, or we can request the nginx application. Next, we define the Portainer at the edge stack. Now, this also uses Cloud Init and Equinix, just like we do above. The user data that we're generating with Cloud Init is just a little bit different, in that we are setting up BGP and a Portainer agent instead of the Portainer installation script, like so. Then we provision the device. This time we are passing in the edge key and the global BGP IP address as custom data so that we can fetch that back down from a user data script. And then we output the worker IP, and we also configure the BGP session. So this is not terribly complicated. It's just 100 and so lines of Terraform CDK. You can pull this, you can run it yourself. It should just work TM. Now down here, we've defined our stacks in Terraform CDK, but we actually need to tell it what to synthesize and what to run. So we generate the application, we create the admin stack. We can now have this new Portainer at the edge stack. We can actually duplicate this as many times as we want to any facility within, or any metro or facility within the Equinix Metal network, and it continues to scale out geographically as much as we want. Perhaps we want more infrastructure on the East Coast and the West Coast of the US. Perhaps we want infrastructure in Central Europe, Western Europe. Perhaps we want infrastructure distributed across Asia. That is up to you. You know your customers. And once you have this stack run up, Portainer does all the heavy lifting. All you need to do is spin up new nodes, join a Portainer cluster, and you're golden. And then we synthesize and we run it. So we have no edge key here. So I'm going to walk you through the process of spinning up the Portainer admin stack, turning on edge compute, getting that key, and then we'll take a look at the edge deployment mechanism. So first step, as you'll see, I've already ran these commands a few times, is to do cdktf deploy admin. This will set up everything that we need to get the edge key available for the edge compute deployments. Now, this is bare metal. It is not a virtual machine on any of the hyperscalers. So we're not going to see this return in 10 seconds, 30 seconds, or even a minute. It's going to be closer to 1 to 2 minutes. So I'm going to go poof, and back in a second. Sweet. We have our admin stack deployed. We have our BGP address, which won't be resolving any traffic at the moment. And we have our admin IP, which will allow us to set up our Portainer instance. Let's copy our admin IP and pop it open in our browser. We will be presented with the Portainer setup screen. We've seen this before, so I'm not going to spend any time on it just now. Put my password, I hit go, and I'm going to provide my license key. Remember, the business edition of Portainer is free for up to 5 nodes. So if you're a small scale deployment like me, take advantage of that. Sign up now. Okay, now that we have Portainer admin node running, the first thing we want to do is go to settings. From here, we can click on Edge Compute, where we turn on the Edge Compute features, and click Save. We then want to scroll down to the Automatic Edge Environment Creation. You will see your admin IP address and port number here. You can disable the waiting room if you want. However, we're going to leave that on so you can see how it works in this demo. Now, because I'm using my CDK Terraform or Terraform CDK automation, I don't need to worry about Edge ID generators or dropping in environment variables into this script here, because it's already done. So just go check out that automation and the Cloud Init configuration scripts to see how I generate those values. The only thing I really want is this edge key here. So we're going to copy this and switch back to VS Code to drop it in. like so. From there, we can run a cdktf deploy, and we're going to deploy US and EU. However, I also specify admin. That's just because the US and EU stacks do have that dependency on the admin stack, so it will force you to specify all three. We click the button, we wait a few moments, and we'll get an approval prompt for 2 stacks to be deployed. We had approved twice. Those devices are now creating on the Equinix Metal platform, and I'll be back in just a moment to show you the next step. Sweet. We now have a worker IP in the US and a worker IP in the EU. Now, before I go to the browser and show you the next step, I do want to push out one caveat. If you're running the same automation and you go to your browser, you may not see the pending nodes right away. The reason this is that cdktf is not waiting for the user data to finish provisioning. So while these bare metal devices are now available and I have IP addresses, the cloud init process is probably still running, and it can take anywhere from 30 seconds up to a minute and a half to complete. That is because it's pulling down a Docker image. It's then starting in the Docker image, it has to register with the Portainer admin instance, blah, 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 blah. Now, because of the power of video, when I go to my browser, things are magically going to be there. But please just remember, it can take a few more seconds. And that being said, let's now go to my Portainer admin instance. So we can click on Edge Devices and click on the waiting room. And we'll see at the moment I have one of my devices waiting. Hit refresh, and by the power and magic of video, now both are available. We can now click on this and say that we're happy to associate these devices with our Portainer cluster. Now, where we click on Edge Devices, we will see that we have Portainer at the edge Frankfurt and Portainer at the edge Dallas. This is our US and European devices. Now, Portainer has a cool feature where you can enable groups. This is not important for today's Edge Stacks demo. However, if you have more than one administrator of your cluster, you may be able to use groups to be able to facilitate access to multiple edge devices with ease. To do so, I will create a group called production. And instead of saying this is static and selecting the 2 machines, I'm going to make this dynamic, and I'm going to base it on environment variables. We can say environment production, and we'll see that the 2 devices already provisioned are now available to add to our edge group. Now again, not important for the stacks demo, but for managing access to more than one edge device, groups are a super cool feature. Next up, we're going to add our edge stack. So we go to Edge Stacks, we click Add, and I'm going to call this nginx. We're going to use a very simple Docker Compose file to deploy nginx to each of our edge locations. We then select the group, so production, and the type of deployment will be Compose. Now, if you go to the repository in the description below, you will see that there is a Docker Compose file. You can copy this or type it, it's very simple. It's just going to deploy nginx and expose it on the host or node port of 8080. And then we say deploy. You'll see here we have status indicators, blue, green, and red. Let's turn on auto refresh to 10 seconds. And you'll see now we have 2 successful environments. Blue for acknowledged and red for failed. If we click on this, and then environments, you'll see that this stack is successfully deployed in both Dallas and Frankfurt. Well, let's go back to our cdktf for just a moment. We have this BGP advertisement here. So let's pop this open in our browser. And if I browse to 8080, we are presented with the nginx webpage. So let's check the performance of our application using a nice web performance checker from KeyCDN. You can go to tools.keycdn.com/performance, where you can drop in your URL and port number and say test. Now, what we see here is pretty standard for web applications, especially deployed in this topology. The latency for European and US websites is pretty high in Asia and Australia. You can see Frankfurt has less than 2 milliseconds response time, or at least a connect time. We have less than 3 milliseconds for time to first byte. This is peak performance. Now, Amsterdam is going to rise a little bit, but you're still on the European continent and the traffic is still pretty decent. And the same for London. Now, New York, being on the East Coast, is a little bit higher, but you can see in Dallas, at least where our infrastructure is actually hosted, we've got less than 4 milliseconds on the connect and 5 milliseconds on the time to first byte. Pop down to San Francisco, we've got the West Coast. So if you're not sure where Dallas is, it's in Texas. It's kind of right in the middle. That's why both the coasts are a little bit slower. But let's look at Singapore. We're waiting over 200 milliseconds for the connect. And we're waiting almost half a second for time to first byte. And Sydney is not much better. 200 milliseconds, or at least 190 milliseconds on the connect, with 373 milliseconds on the time to first byte. Tokyo is high and Bangalore is high. So we can improve this performance. And I'm not going to do anything except for deploy our other stack. Now, the Terraform CDK will provision the instance, our cloud init will install a Portainer agent. Portainer stacks will detect the new device. We will approve it because we have the waiting room turned on. However, you could turn that off. Once we approve that device, Portainer will realize that it is part of our stack configuration. Deploy nginx, we'll be able to rerun the tests, and everything will be super fast and low latency everywhere we go. Let's do it. So let's do our CDK deploy. And remember, because each of our edge deploys have a dependency on the admin stack, we need to add the admin stack too. However, nothing will need to be deployed for the admin stack, and it will just offer us one change for our compute stack, which is our Asian compute node. So, for the last time, I will be back in just a moment. All right, it's almost time for the moment of truth. We now have an IP address for our Asian compute node. So let's head over to the Portainer admin interface and check out our waiting room. And there we go. We have our Singapore instance ready to be associated. If we come to our stacks, hopefully if the refresh is right, although it may be a little too fast. There we go. We got it. We have our acknowledged environment, and if I wait for the automatic refresh in 10 seconds or refresh it myself manually, we should see that turn green. Hey, love it when stuff works. So we can click on this, click on environments, they're all okay. And what I really love about this is that we don't need to worry too much about the management layer of a geographically distributed compute cluster. This is something that Kubernetes is notoriously bad at. Stretching Kubernetes clusters across more than one region is super painful. You pay a lot of money on egress traffic because the communication patterns for the kubelet and the API server were built under the assumption that these things were almost co-located within the same building. Portainer is different, especially with their edge compute semantics. So we have to complete the demo. Let's check key CDN to see the performance of our application. So I'm not going to change anything. It's the same IP address, the same port, but a different topology for our deployment. And those numbers are looking pretty different already. Singapore, we have 3 and 4 milliseconds. Of course, that is where we deployed the other node. Sydney is a little bit higher, but much less than what it was without the Singapore region. And Tokyo and Bangalore have improved slightly as well. So that's pretty cool. And there's just one last thing we haven't looked at, which is edge jobs. Now that we have our geographically distributed compute cluster, with our application being delivered to our customers in a low latency environment using any cache routing with BGP, we may have admin things that we need to run on a regular cadence. And Portainer supports this through edge jobs. So let's assume we wanted to run a backup. We can use cron syntax if we want, or the basic configuration. We can mark this as recurring and say run once per day. From here, we can use whatever script we want. So if you need to back up any of your volumes or your containers or logs to Amazon S3 or GCS or anything like that, script it away. We can select the node or nodes we wish to run it and click create. As simple as that, we have our backups good to go. So that is the edge compute capabilities of Portainer. Coupled with Equinix Metal and BGP written, you can get some pretty impressive architectures to satisfy your customers wherever they are. Join us for the next video in this course. I'm going to be diving deep into how Portainer can enrich Kubernetes. I'm very excited for the next video. I hope you are too. I'll see you soon. Until next time, have a good day.